Welcome to another episode of This Week in Space. This week, we'll be looking at some very special spaceflight anniversaries, NASA's budget, it's more interesting than it sounds, and little bits of Mars. Stay with us.
Podcasts you love.
From people you trust.
This is TWiT.
This is This Week in Space, Episode 6, recorded on April 8th, 2022. Space Anniversaries. This episode of This Week in Space is brought to you by Blue Land. Sometimes in order to go green, you've got to get blue. Blue Land, that is. Blue Land was founded on the belief that a cleaner planet starts by reducing waste while creating powerful, effective cleaners for your entire home. Get 20% off your first order when you go to blueland.com/space. And by IT Pro TV. IT Pro TV has everything you need to level up your IT skills while you enjoy the journey. Visit itpro.tv/twit for an additional 30% off all consumer subscriptions for the lifetime of your active subscription when you use code TWIT30 at checkout. Hello and welcome to another episode of This Week in Space, our first Space Anniversary edition, which was actually suggested by my good friend and co-host Tarek Malik, who won't be here today because he's stuck in the air in a delayed flight winging over the Midwest as we speak, coming back from Space Symposium, which is the largest space conference of the year held in Colorado. And he chaired or moderated a big panel with National Oceanic and NOAA, whatever that stands for, Oceanic and Atmospheric Administration, and a bunch of other really important people. So he had to do that, so he won't be joining us today. But I'm going to tell him a joke anyway. Say, Tarek, why didn't the sun go to grad school? I don't know, Rod. Why didn't the sun go to grad school? Because it already had 1,000,000 degrees. Here we are again, and we're going to talk about some cool space anniversaries because you can never have too many anniversaries. But first, let's look at some headlines. Waiting on a Mars bar. It was recently announced that the samples of the Martian surface taken by the Perseverance rover won't be picked up and returned to Earth till at least 2033, and that's at the earliest, which means that by the time they're retrieved, some of those samples will have sat on the red planet's surface for over a decade, 11 or 12 years, because we've already taken some drill cores with Perseverance. Now, this is due at least in part to the money required for America's return to the moon with the Artemis astronauts, hopefully in around 2026, 2027, because a lot of money is being spent on that program. But the sample return program for bits of the Martian surface is something that's really been in work for about a decade and has been talked about and dreamed of for at least 50 years. This is kind of the holy grail of planetary science. There's a lot of things you want to do in planetary science, but a big one is bring back parts of another planet. We've got parts of comets back. We've got little bits of asteroids. But what we don't have is a pristine sample from the Martian surface. And this would help answer so many questions. You might even find microbial life in there, but more likely, if you find anything, it's going to be just basic organics. But we want to know what the soil's like. It's been analyzed on the surface by laboratories on the rovers, Curiosity and Perseverance included, but there's only so much you can do. You can't carry a full geochemical analysis system up on a rover. So this is something that we've really been looking forward to for a long time, but alas, it's going to be delayed a bit. And I'll just add, it's really complex, so there's a reason this is taking longer. Part of it's money, but part of it's that's really hard to do. So the Perseverance rover takes these drill core samples that are about the size of a small cigar in a little titanium tube and stores them for later pickup, because obviously that rover can't fly back to Earth. It's not equipped to do that. So what you have to do then in the 2030s, we're presuming, is send another rover up called a fetch rover that wanders along behind Perseverance and picks up these samples, whether they're dropped behind it or stored on the rover, it depends, stored on Perseverance, picks up those sample tubes, drives them back to another lander, which has a Mars Ascent Vehicle, or MAV, on it. They've got to cross-load those sample tubes to the MAV, shoot that up to Martian orbit, rendezvous with another spacecraft, and shoot it back to Earth. So it's a big involved multi-step process, which is why we haven't done it till now. It was a little disturbing to some of us watching the Perseverance rover program get planned because we knew it was going to be taking all these samples, but we also knew that there had not yet been a major budget appropriation to bring back those samples. So this is all part of the mix. So the good news is it'll happen. The bad news is it's going to take longer than we wanted. And, you know, by the time those samples get back, Elon may have already landed Starship on Mars. But I guess we'll see. Moving along. Oh, there is one more thing that complicates returning Martian samples. We have a thing called planetary protection, which means we want to protect Earth from nasties coming back from other planets. So when we send spacecraft to Mars and land there, we try to protect the Martian surface from earthly microbes by keeping our spacecraft very clean. When we're bringing stuff back, however, that amps up by a factor of about 4 million because we don't want some germ coming back on a Mars rock and growing into a 90-foot tentacled monster that destroys New York. So you got to be very careful in terms of keeping this stuff, keeping it a sealed environment. So basically, it's like dealing with you have to assume you're dealing with major exopathogens, which is something that we want to be very careful about. So that it does add complication. Next up, budget busters. So the White House recently announced its request for NASA's 2023 budget. And this is always a big moment for space journalists because it tells us, A, what the White House is asking for, B, we get to prognosticate about what we think they'll actually get, and C, then that tells us what will be happening for the next few years. So this year's request is a record breaker at $26 billion with a B. That's almost $2 billion more than 2022's, and the largest number we've ever seen for NASA specifically. Part of what's remarkable about this, as I think we were discussing last week, is this is the first time that I can remember that two successive presidential administrations from opposite sides of the aisle actually continued their space programs. Usually things get canceled, shuffled around. It results in a lot of waste and money spent on programs that don't end up flying or are just studied to death. So it's a wonderful thing to see because whatever you thought of the previous administration, the fact that this administration, the Biden administration, has picked up what was started in the Trump administration and carried it forward is a great moment for continuity and a great moment for efficiency and effectiveness and how this money is spent. So this sounds like a lot of money. This is still only about a tenth of what NASA was spending during the space race in the 1960s in terms of real spendable money, but it's a record for now. So a large percentage of this will go to the Artemis lunar landing program to return Americans to the moon with the first woman and the first person of color among them, hopefully on that first landing for Artemis 3. Included in the new budget discussion is a crewed Mars mission by 2040. Now, we've been talking about Mars, of course, for years, since the 1960s, actually, about sending people to Mars. We had a sort of wide-ranging discussion about, well, we're going to get back to Mars eventually during the Obama administration, but this is slightly more serious with a little more of a clock ticking on it. So it's a good thing to have a date. 2040 is way out there, but at least we've got a year, 18 years in the future. $1.5 billion is for the new human landing system that's being developed by SpaceX to take the astronauts from the Orion capsule in lunar orbit down to the lunar surface. And that will soon include a second vendor, probably Blue Origin and their national team, to build another lander, and that will gobble up a bunch of money as well. The SLS, Space Launch System, and Orion will devour another $4.78 billion because they are money-eating machines, those two spacecraft. And that $4.78 billion is a little bit more than what's being estimated for a single launch of the Space Launch System. That's another conversation. But that's a big chunk of NASA's budget. Mars sample return, as we just discussed it, gets $822 million. That's just for the year. There will be more. Sadly, a program called the Mars Ice Mapper mission was terminated in this budget request. And that was a Trump-era mission request. And the idea was to send an orbiter to Mars to specifically map where the water ice is, which is really important because part of the way you get back from Mars is to have resources there that you can use to make fuel to get home and to make breathable oxygen and so forth. So we want to know where the water is, but probably it's more important to be able to map it on the moon for now. So Mars can wait, but it's unfortunate that got scrapped. The high-altitude aircraft-mounted SOFIA telescope, which is an instrument that's been working for probably close to 20 years, maybe a little more, pointing out the side of a converted 747 passenger aircraft, is being canceled finally. They've been threatened with termination for, 7-8 years, but it looks like it's finally going to happen in this budget. But this all depends on what Congress decides to do with it. The ISS, International Space Station, remains about the same at $1.3 billion a year, so that's a maintenance level budget, and that's just what you have to do to keep it up there till 2030, because we want it to stay in space until we're done with it. And finally, the Near Earth Object Surveyor Space Telescope, which is intended to go into low Earth orbit and look for dangerous objects that could eventually intersect with and threaten the Earth, would be delayed for 2 more years. It's been delayed a bunch of times. I think I started tracking this program in 2007, 2010. It's gone by various names, NeoCam, NeoWise. It's finally been resuscitated as the Near Earth Object Surveyor Space Telescope. They'll probably name it after somebody that they want to flatter before it launches. Anyway, that's been delayed, but at least it'll still go. And it's important because we want to know what's out there and what's on its way towards Earth. And by the way, all these headlines can be tracked over at space.com. That's where we get our feeds from. Thanks to Tarek, who's not here. Oh, did I already say that? Finally, AX-1 is on its way. So Axiom Space's first all commercial flight to the space station lifted off from the Kennedy Space Center this morning at about 11:17 Eastern Time. And this is the first all-private mission to the International Space Station, being commanded by our friend, the astronaut, Michael Lopez Alegria. And it's exciting on a bunch of fronts. We talked about it last week. So definitely something to watch, something to track. They're going to spend more or less 20 hours in orbit catching up to the space station, and they should rendezvous and dock about 7:45 a.m. Eastern Time tomorrow. And hopefully some of you will be up to watch that. I won't, but you might be. So check all that out on space.com. We'll have links. So let's get into the meat of our program, Space Anniversaries, and we'll be back shortly after a message from our valued sponsor, Blue Land. This episode of This Week of Space is brought to you by Blue Land. Did you know that an estimated 5 billion plastic hand soap and cleaning bottles are thrown away each year? And as if that's not bad enough, each bottle contains as much as 90% water. That's a serious lose-lose situation for the planet. This plastic has been found in all marine turtles, almost 60% of whales, 36% of seals, and 40% of seabird species examined. By 2050, scientists predict that the ocean will contain more plastic by weight than fish. Think about that. Of all the fish in the ocean, all of them, there's going to be more plastic mass than there are fish. That's really scary. So let's start creating a cleaner planet from home. Blue Land's idea is very simple, and it's beautiful. Buy the bottle once, refill it forever. No more plastic waste. The only thing you have to discard is your outdated idea that eco-friendly products are more expensive or less effective than conventional ones. They're not. They're much better. You just fill Blue Land's beautiful Instagrammable bottles with warm water, pop in one of the hand soap or spray cleaner tablets, and within minutes you have powerful cleaning products in the most incredible scents such as iris agave, perrine lemon, and lavender eucalyptus. From their best-selling Clean Essentials kit to their hand soap duo and plastic-free laundry and dishwasher tablets, Blue Land is something for every inch of your home. And backed by popular demand is Blue Land's toilet tablet cleaner. Get it before it sells out again. Blue Land's stunning high-quality forever bottles start at just $10 when you buy a kit and are meant to be reused forever, with money-saving refill tablets that start at just $2. And I have to tell you, we got our first shipment of Blue Land products in my home a few weeks ago, and I'm not kidding when I tell you there were squeals of delight when we saw not just how smartly these were designed, but how attractive they were. These bottles are of high-quality plastic. Yes, they're plastic, but remember, you're using them forever. They're beautifully colored, and the refill supplies are designed brilliantly, and all that packaging is made with paper. So this is a buy once, use many times system that I think you're going to love. Again, it's very attractive. They make a lot of sense, and they're easy to use. You're not compromising ease of use for doing the right thing to the planet. This system is designed wonderfully. Try Blue Land today. You'll love it, and your planet will thank you. Right now, you can get 20% off your first order when you go to blueland.com/space. That's 20% off your first order of any Blue Land products at blueland.com/space. blueland.com/space. All right, it's time to look at some important to me anyway, space anniversaries, and we'll start with the one I think is the coolest, if you don't mind, if you'll indulge me, the flight of Apollo 16. Now, people of a certain age, like myself, remember this firsthand. There's statistically going to be fewer and fewer of us moving ahead. And so for a lot of younger folks, the space race is kind of a footnote in the history books or a documentary on the Discovery Channel or something that they read a tweet or a post about. And that's okay. I mean, that's just the way of the world. That's how things go. But if you were alive at that time, it was really an amazing thing. And what's odd about it to me is the further I get from it, the more shocked I am in hindsight that it worked. We were still basically flying airplanes with evolved World War II technology. By the time we landed on the moon, we only had transistors for less than a decade. Prior to that, it was the vacuum tube era. And in fact, some of the Russian spacecraft did fly with vacuum tubes early on. And some of you may not know what a vacuum tube is, but it's a large, bulky, fragile version of a transistor that didn't work very well over time. So when you look back at the space race from that perspective, it's fairly jaw-dropping. So that's why I wanted to sort of focus on the anniversary of Apollo 16, because it was the 5th lunar landing. These things were happening in rapid succession. If you were around then, you'd see these missions taking off as often as every 2 months. And they'd fly out to the moon a couple of days, they'd land, spend 3.5 days on the surface, and fly back to Earth. Whole thing would take a little less than 2 weeks. Pretty amazing stuff. Now, if you grew up during the shuttle years, you were lucky if you saw a mission every 3 or 4 months. It was supposed to fly every week. We never got there. So compared to that, it was pretty amazing. And even today, with all the stuff that's happening, which we talk about on this show, thinking about moon exploration happening every 2 months in a major fashion for a couple of years is kind of jaw-dropping. And when you think about it being done with 1960s technology, and these guys were flying right on the edge, right on the bitter edge of what could actually be done with that technology, it just blows me away. So let's talk about it, because as you could tell, I'm kind of excited. So Apollo 16 was the 5th lunar landing. We had our first landing, which was really kind of an engineering proof of concept mission, Apollo 11, in July 1969. Then Apollo 12 landed shortly after that. Apollo 11 landing was kind of touch and go. Apollo 12 was pretty much by the numbers. Apollo 13 didn't make it down the moon's surface because, as you will recall, that spacecraft suffered an explosion as it was transiting from the Earth to the moon. But Apollo 14 and 15, by this point, had very smooth landings. It was kind of by the numbers. It was still incredibly dangerous flying with these very rudimentary spacecraft, but the system worked. And while they were fairly basic technologically, as we would look at it from today's viewpoint, NASA had really ironed out the bugs by this time, and things were just by the numbers. So Apollo 16 was the 5th landing. It was called the J-class mission, the second of the J-class missions, which means that it was a better provisioned LEM. It could carry more weight. It had more hover time. It had more robust life support systems. But perhaps most importantly, it had a car. It had a lunar rover tucked in the side of the descent stage. So after these guys landed, they lowered this big panel, and this car unfolds. And it literally is packed up like a suitcase with wheels. So once they landed on the moon, and they got out, the 2 astronauts got outside, and they opened the side of the cargo bay on the lunar module. These four wheels unfold, and then the whole thing flips down, and you've got this beach buggy for the sand of the moon. So it's all pretty amazing. So I'm going to talk a little more about that when we get there. In addition to this, so this meant that the J-class mission meant that they could stay on the moon longer. They could have up to 3 extravehicular activities, or EVAs, moonwalks, essentially, and they could stay there for days. Finally, the crews had more training than their predecessors, especially the first couple landings, in geology. So while they weren't college graduate level geologists, they had had a lot of training from Caltech, a professor at Caltech, and for the astronaut that stayed in orbit with the command module, a gentleman from MIT. And this meant that they could collect better samples. It's important for the person on site to know what they're doing. And we only had one trained geologist who went to the moon. That was Apollo 17, a guy named Harrison Schmitt. So for the other missions, you wanted to train these astronauts who were essentially aeronautical engineers and test pilots to be the best geologists they could. So they had spent time, they had had more time with this crew than they had with some of the others. So this was a plus. So flying on Apollo 16 was John Young. He was a seasoned Gemini veteran, had flown in the Gemini program. He was the commander of the mission. Charlie Duke, who was the youngest and perhaps most exuberant of the Apollo astronaut cadre, was the lunar module pilot. And Ken Mattingly was the command module pilot. And he, if you saw the movie Apollo 13, was the guy that was supposed to fly on Apollo 13 as the command module pilot and was bounced at the last minute because he was exposed to measles. So this was his chance to finally get out to the moon. The mission landed in a region called Descartes, which was a particularly bright part of the lunar surface on the side facing the Earth, roughly near the equator. And it was thought that it might be associated with lunar volcanism, that this might be the result of a huge volcanic eruption at some point, which was something that geologists were very interested in learning about the moon. How much volcanic activity did it have during its formative years? Both Apollo 14 and 15 had landed in areas associated with a region called the Mare Imbrium Impact Basin, and they had studied those rocks and were getting good results from that. Did turn out not to be volcanic. But they wanted to move, they hoped, away from that region so they could get samples of something completely different. So that was a large part of the motivation for landing at Descartes. Now, if one is to characterize the overall tone of Apollo 16, I'd say it was an ideal combination of exuberant and laconic. Exuberant for the excitable and impassioned Charlie Duke, who, as I said, was the youngest of the astronauts. And I'm going to play some clips because I just think it was so much fun to listen to these guys hop around the moon. They were having a great time. And laconic for John Young, with his kind of down-home country boy, nothing impresses me drawl. So the excitement begins with the landing. And just for you purists out there, for the ribbit counters in the room, yes, I've edited these things down a lot because otherwise we'd be here for the next 42 hours, and I don't think most of you have that much patience. So I have cut these down. They're very compressed, but I think it keeps the tone of the mission and the tone of the moment. So the landing, as I said, was fairly routine until they got to the surface, and then these two guys in particular, Charlie Duke, can barely contain themselves. Roll clip 1, please.
Okay, down at 3, 50 feet, down at 4, give me 1 click up. You're backing up slightly. Okay, 2 down, stand by for contact. I'm going to let her down, you level off. Contact, stop. Move. Throw, engine arm. Okay, 413. Well, we don't have to walk far to pick up blocks, Houston. We're in front of them. Oh, the run is finally here, Houston. Fantastic. Okay, we're forward to the north of double spot. I would guess about 200 meters to the north and maybe 150 meters to the west. Fantastic. Percy Precision is planted one on the plains of Descartes. Man, it sure ain't flat, John. Wow, there's that ridge to the north. Yep, sure is. All we got to do is jump out the hatch, and we got plenty of rocks.
Ready, we copy.
What a neat place.
What a neat place. So this kind of gives you an idea of how these guys are experiencing the moon. I mean, this is a scary thing. You're taking this fragile machine. The astronauts referred to the lunar module as the aluminum balloon because by the time that Grumman Aerospace had it light enough to fly to the moon and back, the hull was so thin, the pressure hull where the astronauts flew from, that it literally expanded when they pumped it up to 5 pounds per square inch in the vacuum of space. So it was about double the thickness of a Coke can. So imagine flying on that to the moon and counting on that at getting you home. And by the way, you're living in it for 3 days as well. So to hear these guys as laid back and having as much fun as they are in the middle of what for most of us would be a terrifying experience just blows me away. So they land soon after. They leave the lunar module. They're all suited up. They're going to make their first EVA. They put out an experimental package called ALSEP on the surface of the moon with a nuclear power supply. So that's going to detect moonquakes if there are any, and other scientific measurements for a couple of years. But the goal here is to get in that rover and get driving, because prior to this, all the astronauts had to walk wherever they were going on the moon. And even though it's only about 16% of Earth's gravity, walking in those pressure suits is not a pleasant thing. They're very stiff, they're very bulky, they're very clumsy, and it made it difficult, which is partly why they developed the bunny hop to get around. But, if you want to explore, you really want to be able to drive places so that you're not just trudging from spot to spot, picking up rocks you can see in line of sight. So they had a bunch of targets identified on a lunar map near this landing site, which they nailed, by the way. And so they wanted to get on that rover and get to driving. So soon they're driving their first geological stop, and Charlie Duke is giving this kind of excited running narrative of the scenery and twisting this way and that and taking pictures. And he keeps bumping into John Young's arm. Now, the lunar rover was obviously very small because it needed to be compact to be folded up and stuck in the bottom of the landing module, of the landing stage. And it looked basically like a flat table with 4 wheels and 2 beach chairs on it. There's a handle in between the 2 chairs to steer it. Either astronaut could steer it in theory. So John Young sitting in the left, in the driver's seat, and Charlie Duke sitting in the right. And every time Duke would move, he'd bump into John Young's arm. And every time he'd bump into John Young's arm, the steering bar would twist. It wasn't a wheel. It was kind of like a joystick. It would twist and would send them off course a little bit. And Young was getting increasingly irritable because he didn't want to end up driving them to a crater and ending the mission right then and there. But Duke just had trouble controlling himself. So we've got a clip of this first drive, and you'll hear, if you listen carefully, you'll hear Young say a couple of times, "Charlie, you're hitting my arm. Charlie, stop hitting my arm." He's getting increasingly uptight about it. And Duke is just going nuts describing the scenery. Roll clip 2, please.
There you can see South Ray Crater with just tremendous amount of blocks on it with some black streaks. And here we go. 274, John. Okay. And it's going to be a piece of cake taking pictures from here, Tony. The big crater, there's about a 10 meter off to your left there, John. I see it. There's a deepy one over here. 4 clicks an hour, Tony, and Charlie, you hit my arm. Excuse me. I'll end up in that big crater. Oh, man. Charlie, you hit my arm.
And have you seen any rocks that you're certain aren't wretched?
Quit hitting my arm. And we're Zeke. That's Spook. How big is Spook? 300 meters? There it is. There's the Buster. I mean, there's Flag. We're here. You did it. It sure is. We are here.
So what you're seeing, there was no television coming back from the drives. They have a TV cam on the rover, but it didn't run during the drives. It ran once they stopped, and the operator at Mission Control could pan back and forth and so forth. So what you're seeing, if you're looking at the video stream of this at some point, is 16 millimeter footage taken from a movie camera that has the TV camera on the rover actually down the foreground. So these were the days before we had data cards for video recording, before we had high-def video recording, before we had any of this stuff we take for granted now. So we had very fuzzy, low-resolution television coming back from parts of the moonwalks, but the landing of the lunar module, a lot of the footage inside the command module, the Apollo capsule, and the footage taken during the drives from point to point on the moon was all on 16-millimeter celluloid film. And nobody saw it until it came back to Earth because it had to be processed in the chemical bath, for those of you who remember film-based photography. So all seems fairly primitive when you look at it from today's perspective. So they made a number of stops during each of their EVAs. There's 3 of them, getting off and on and off the rover and taking samples from various targets of interest. Some of these included really large boulders, and I'm talking maybe 25, 30 feet high in at least one case. But when they jumped out to take these samples, their geological training kind of became a little more obvious. So I just wanted to play a short clip of a little bit of that demonstration. So roll clip 3, please.
The size of that rock. John, I reached back in there pull your visor up and look under there. I reached in there about 2 to 3 feet, looked like to me. Oh, that there is one of those gopher holes. Yeah.
Hey, John, you think you can push that one over?
Do that in West Texas and you do that in West Texas and you get a rattlesnake. Here you get permanently shattered soil. One thing about this rock is it has some, this is the one that I noticed when we're coming up the way that has some, these holes in it look like vesicles, Charlie. Yep, they sure do, big ones, biggies. No, I'm out of film, I think. Couldn't be zap holes. Look at this. Tony, this is the black matrix with some excellent crystals in it, and also that are milky in color. Don't see any cleavage, though, or striations. About a centimeter across, and it has a matrix of the white, of that white rock, like up on the rim. Not a matrix, but some clast of that.
So you can hear him talking in some detail about the geological features they're seeing. And to most people, this is not terribly interesting, but they were obviously interested. And probably, I took a lot of geology in college. I was a geology major for a while. I went on field trips with these guys. I've gone out on a couple of NASA field trips with the people working on the Mars rover programs, just as introductions for the press. And while geologists can get kind of worked up about certain things, you know, whether it's soil chemistry or rock formation or strata, whatever, I'd never heard anybody get quite as worked up as Charlie Duke was about, wow, look at those crystals. And I just love the kind of down-home accent that they've got and the way they handled this all in a very laid-back fashion. So I'm going to jump to my final clip. And this is the clickbait for the show, I guess. In the one and only time I know of this to happen on the moon, while on the moon's surface in a way that was possibly in some way compromising, we had what we call a hot mic or open mic issue. And those of you familiar with radio will know what I'm talking about. There's times when you want to be on microphone. There's times when you want to be off microphone. If you're at a conference giving the keynote, you want to be off microphone when you're using the restroom, for instance, for obvious reasons. So we had a hot mic moment on Apollo 16. So the background of this is during Apollo 15, they had recorded some heart arrhythmia on Jim Irwin, one of the moonwalkers, and they thought, you know, maybe this has something to do with low gravity, could be radiation, it could be a lot of things. Let's add some potassium to their diet, try and stabilize their pulse. So they had Duke and Young drinking lots and lots of orange juice. I guess that was better than giving them a pill for it. So they would, during the flight, in flight, before landing, once they're on the moon surface, they kept saying, okay, time to push some more orange juice. Got to drink that orange juice. Don't forget to drink your orange juice at dinner. Have some orange juice with breakfast. And it was beginning to wear a little bit because astronauts are people too. And even though they may seem superhuman, at least when they're on the moon, they get tired of things. So we had an incident where Young was beginning to experience some flatulence which he felt was probably because of all the citric acid in the orange juice. So after that first EVA that we just played the clips from, well, they were winding down and preparing to go to sleep that night in the lunar module on the moon. And remember, this is only about 230 cubic feet. So if you have a release of personal gas in that space, it's a very small space you have to sleep in, and it hangs around because there's nowhere to go. And the filters are only so effective at taking it out. So you didn't want to have flatulence on the moon unless you were somebody that you really didn't like very much. So there was a brief commentary between Young and Duke about the after effects of drinking this much orange juice. And they didn't realize, as you'll hear, that they were transmitting to the wide world on an open mic, a misapprehension that Mission Control collected as quickly and as unobtrusively as they possibly could. Roll clip 5, please.
I got the forks again. I've got them again, Charlie. I haven't eaten this much citrus fruit in 20 years. So I'll tell you one thing. In another 12 days, I ain't never eating any more. I put them up over the... right up in there. They ain't there?
Orion, Houston.
Yes, sir.
Okay, John, you way have a hot mic.
How long we had that?
So I put in the censorship tones for public consumption, but it was a bit of a moment, and they got a little bit of a finger shake when they got home. And that was, as far as I know, the second time anybody swore from the moon. On Apollo 10, which was an approach and landing test that didn't actually set down, they had an incident when they staged the lunar module and the top stage started spinning. And it was a very dangerous, scary moment. And the 2 test pilots flying that mission had a few choice words to say and got a thorough chewing out when they got home. But you know what? In this case, if it's just because you've got gas, yeah, I could see getting a little bent at these guys for mouthing off on the moon in an important mission. But, you know, if it's a life and death situation where you're spinning at a high rate of gyrations and at a dangerously low altitude that could slam into the side of a lunar mountain, I say give the guys a break. But that's just me. So this is a spectacular mission. After the completion of it, and as Apollo 17 was preparing for America's final voyage to the moon, the geologists started working on the rock and soil samples that came back and ultimately determined that the samples were not volcanic in nature. In fact, many of the samples appeared to be related to those taken at the site where Apollo 14 landed, called Fra Mauro. So the mystery of the origins of the moon continued. In the ensuing decades, we've learned a lot more about the formation of the moon. And in fact, basic theories about the formation of the moon have changed since then. But a lot of that's based on the results we got back from the Apollo missions. Moving ahead into the Artemis program, part of the goal is to get off the equator of the moon. All the Apollo missions were more or less on the equator because that was the safest place to aim for and land. Range a little further north and south, ultimately to the lunar South Pole, where we think the vast water reserves are, and really start exploring our satellite in a comprehensive, sustainable way. But for its time and for the amount of money that was available and the technology was available, Apollo was really something. So after 16 wrapped up, Charlie Duke retired fairly shortly thereafter in 1975 from NASA. Went on to private industry. As I recall, at one point he was in liquor distribution. He also became a pastor and ended up spending a lot of time preaching from the pulpit, which is always interesting when an astronaut does that. John Young and Ken Mattingly went on to fly the space shuttle. Young commanded the first flight to orbit of the space shuttle, as well as the 9th, and became the first person to fly into space 6 times, starting with the Gemini program. And he ended up staying with NASA until 2004, by which time he was fairly elderly, but he was considered by many to be sort of the most seasoned of the astronauts, and he was definitely the go-to guy when you needed help with an engineering problem or with something to do with procedures of space, because he had sort of seen it all. Ken Mattingly commanded STS-4, the 4th flight of the shuttle, in 1982, and another in 1985 before retiring from NASA. So that wraps up my look at Apollo 16. I apologize for spending so much time on this one anniversary, but It was just such an amazing thing to see firsthand. I strongly encourage you to go on YouTube. Not necessarily for Apollo 16, any of the moonwalks, but take a look at some of these videos. They're really pretty amazing. There are a lot of cut down reels now, so you can see all the falls that they took, which are usually put against funny music, but it's actually very dangerous to fall on the moon because if you crunch up your backpack, your oxygen supply stops and you're a long way from the lunar module. But if you look at particular at Apollo 12, Apollo 16 and 17, they each have some really spectacular high points. Apollo 12 was Al Bean and Pete Conrad. Those guys loved each other like brothers, and like this mission, they were just having a great time up there, cracking lots of jokes, having a blast. Unfortunately, there's video of it because the camera broke, but you can listen to the audio feed and see stills. Anyway, I encourage you to check it out, and don't be shy about emailing me and telling me that was great, or, hey, I really loved going and watching those moonwalks, or, Rod, why did you spend so much time talking about something I can't see? You take your pick, but don't be shy about writing in. We'll be back with more Space Anniversaries after a word from IT Pro TV. This episode of This Week in Space is brought to you by IT Pro TV. The world of IT is colossal and always changing, so where do you start to get the updated certs and training you need? Whether you're a seasoned IT professional or just getting started, IT Pro TV is the online learning IT education platform you need to advance your skills in IT. IT Pro TV has 7 studios, and they film Monday through Friday every week. They have the most up-to-date content with every vendor and skill that you need to advance your IT career. Their courses go from the studio to their course library in 24 hours, and they're divided into 20 to 30-minute episodes for easy binging. They make sure you're prepared for your exams with their virtual labs and practice tests. The best part about IT Pro TV is that you can learn and get certified on your own schedule, and it's entertaining. Now, April is Linux month at IT Pro TV. Check out the on-demand webinar with Don Pizzette and Daniel Lowry focused on choosing the right Linux distro in 2022. You're going to enjoy it for sure. And IT Pro TV's Linux Free Weekend is scheduled for April 23rd through the 24th. You won't want to miss that. IT Pro TV has over 138 hours of Linux training available. Here's a couple of courses you may want to check out. Linux Shell Scripting Basics, LPIC2 Linux Engineer, or Linux Command Line, plus so many more. And don't forget about your IT team. Check out an IT Pro TV business plan for your team today. Visit itpro.tv/twit for an additional 30% off all consumer subscriptions for the lifetime of your active subscription when you use code TWIT30. That's itpro.tv/twit and use code TWIT30 for an additional 30% off for the lifetime of your active subscription. IT Pro TV. Build or expand your IT career and enjoy the journey. And we're back. So let me just cover a couple of other anniversaries. This year is the 32nd anniversary of the launch of the Hubble Space Telescope in 1990 on the Space Shuttle, a machine that's still functioning despite early issues with focus, which we've discussed on this show. It was flown with a mirror that wasn't collimated quite properly, so the first pictures that came back were a little soft, but subsequent shuttle mission was able to fix that. And it turned out to be the gift that just kept giving for NASA. I mean, this was the best PR tool they had ever had, possibly even greater than the moon landings over time, because it's been going on so long. So certainly in the 21st century, it's one of their strongest public relations tools. The pictures are spectacular. The science is great. It's generated 19,000 peer-reviewed papers and something like 500,000 mentions in others. There's more stuff coming all the time. As we discussed last week, it recently imaged the farthest star ever, oldest, which is something that we hadn't seen before. We'd seen galaxies, but we hadn't seen an individual star back at the 12, 13 billion year time scale. So that is pretty astonishing. And that's just one example of many, many, many things that they've found. It nailed down the age of the universe, which before the flight of the Hubble was thought to be somewhere between 10 and 20 billion years, nailed it down about 13.7. Discovered the acceleration of the speed of the acceleration of the universe's expansion. I didn't put that very well, but you know what I'm talking about. Spotted black holes at the centers of galaxies. And perhaps most remarkably, at least in terms of visuals, documented the impact of comet Shoemaker-Levy on Jupiter in 1994. And we actually watched chunks of this comet kind of in a long train of rocks go slamming into Jupiter, which had that been Earth would have been a very bad day for us. But it was something we were able to watch safely from a distance. Told us a lot about the dynamics of planetary collisions. Also made observations of Pluto and objects out in the Kuiper Belt, which is the region of the solar system beyond Pluto's orbit, Eris and others, and helped plan the final stops of the New Horizon mission using the Hubble. It added a lot to the raster of exoplanet discoveries. And in 2015, had a kind of spectacular moment where it documented the reappearance of the supernova Refsdal via gravitational lensing. So this is a supernova that they had seen in process through gravitational lensing that disappeared as it moved behind the large object that was causing the lensing. Remember, gravitational lensing is where gravity actually refracts the light and magnifies the distant object you're seeing, and then it popped back, so it was able to time that out. So a spectacular mission all in all. Sadly, it can't last forever. Might go another 6 years, might go another 8 or 10 years. There are consumables involved. There's maneuvering fuel and gyroscopes, and the gyroscopes do wear out. They've been replaced a couple of times. But it can't last forever, and we no longer have a space shuttle, and it's uncertain whether something like a Crew Dragon or a SpaceX Crew Dragon or Starship could successfully fly a resupply mission. So that's something to be looked at in the future, but for now, it's just a spectacular instrument, and hats off to you, Hubble. Also, on the anniversary roster, we have Pioneer 11, which was launched on April 5th, 1973. This was one of the first 2 missions to go out into the deep solar system, out beyond the asteroid belt, and launched in conjunction with Pioneer 10. Now, these were the predecessors to the Voyager missions. We all know Voyager, big, spectacular program. In itself, it was a cut down of another program called the Grand Tour, but Voyager was still pretty spectacular. So Pioneer was kind of the predecessor of this. Smaller spacecraft, simpler spacecraft, just designed to get our first peek at the outer solar system, because nothing had been out there before. This is the early 1970s. It's only a couple years after the moon landings. So this was the first, Pioneer 11 did the first encounter with Saturn. And when I say encounter, I mean a flyby. These are not orbital missions. They simply flew by. We last contacted it in 1995. It was the first spacecraft to develop a trajectory and speed that would take it out beyond the solar system. And also the early use of using radioactive fuel sources. So it had a device called a radioisotope thermoelectric generator, which is basically a plug of radioactive material that generates heat that's converted into electricity. So Pioneer 10 and 11 were the first deep space spacecraft and the first to use that for an extended power supply. It was spin stabilized, which is kind of interesting. So the whole thing spins around, and the instruments are mounted in such a way that they could still work accordingly. But if you see video of the Pioneers, they're turning all the time. And while they provided some spectacular photographs of Jupiter and Saturn and parts of their realm of the solar system, those were not really, there wasn't a camera in the traditional sense that we think of it on this mission. There was a photopolarimeter that was on that was mounted on the spacecraft that swept past the target. So if you're looking at Jupiter, it would sweep past Jupiter, taking in imagery in the blue and red part of the light spectrum. And then that stuff came back to JPL and it had to be reassembled. And it was fairly low res. And it was kind of a compromise system because the big cameras were going up on Voyager. But for what it was, the processing work that JPL did was spectacular. We got these incredible images, even some time lapses created from these very early missions, and from having never been out there and never seen this stuff except these planets, except through hazy images through Earth-based telescopes, it was an incredible moment. So great missions. Oh, by the way, since this is part of the TWiT empire, the computer was extremely basic. So all the computation was actually done on Earth and then relayed up to the spacecraft and back and up and back. And it could hold up to 5 commands of the 222 preset orders that could be loaded to its memory. It could only hold 5 at a time. And for those of you who understand these things, it had instrument data memory of 6,144 bytes, which ain't much even by floppy disk standards. So that was the Pioneer. They have both since headed out of the solar system, and we haven't had contact with them for a couple of decades. We do still talk to Voyager 1 and 2 because they're more substantial spacecraft and are still returning data. Finally, the anniversary of Apollo 6, which nobody hears much about, launched in April 1968. Notable for being the last uncrewed test of a Saturn V prior to the launch of Apollo 8, which is the first crew to fly on a Saturn V in 1968. That rocket, for something that was brand new and relatively untried, had a very short testing program. I mean, this was breaking every record that there was at the time. And in terms of single chamber rocket engine sizes, still does, and in terms of lifting capability and so forth. Only a handful of test flights. Each one had some issues. And on Apollo 6, the engines, they had this thing called the pogo effect, where the engines would sort of pulse and vibrate. And it ended up actually damaging a couple of engines on the second stage. But the Marshall Space Flight Center and Werner von Braun decided it's okay, we understand it, we can fix it before we have to fly the Apollo 8 mission. The pace at which this program was moving is unthinkable today. Only SpaceX even comes close. Because if this was today, we'd fly another test, and we'd study it, and we'd do computer simulations, and we'd scratch our chins and worry and sweat. And it's the right thing to do when you've got people's lives at stake. But back in this era, we were moving fast and furious. We had a deadline of the end of the decade to land on the moon from a martyred president, John F. Kennedy, and it just had to be done. So this was the final test flight of the Saturn V, and as I said, it resulted in the pogo effect, the bouncing, resulted in the damage of a couple of engines on the second stage. But inadvertently, that was kind of a good thing because it allowed them to test burning that stage and the successive stage longer to see if they could get the same result of using fewer engines burning for a longer time, because they're all pulling from a common fuel source, so that just works. So that's it. We're not going to see anything very similar to that until the orbital tests of Starship, which should be coming up later this year, and we'll certainly be reporting on those. So what's coming up in the next couple of weeks? Well, Yuri's Night. If you've never been to Yuri's Night, you should go. They're all over the world. They're all over the United States. It's a pretty remarkable thing. An organization set this up, I guess, about 10 years ago. And these are global parties, 113 events in 30 countries on 7 continents. Astronauts show up, NASA officials show up, all kinds of people from the private space industry show up. And you can go to their website at yurisnight.net. That's one word, Yurisnight, YURISNIGHT.net. I don't know how anybody uses a .net domain anymore, but there you go. And get all the information you want. There is a fee to go, but I could tell you they're really spectacular. And if you're just looking for a fun way to get engaged and exposed to more of the kind of stuff that you're interested in because you're listening to the show, Yuri's Night is a great way to do it. I've only swung by the one in Los Angeles, and their 2 signature events on their website are signature event in Los Angeles on April 9th, and the Yuri's Night on the Space Coast in Florida on April 16th. But if you go to the website, you'll see that they're all over the place. And there's undoubtedly one within driving distance of you, unless you live in Saskatchewan or someplace like that. So very worth checking out, and I highly recommend it. It's the people that run it are really spectacular. One additional note to that, however, the Space Symposium, where our friend and co-host Tarek was attending this week and is now flying back from while I talk to you, got into a bit of a squeeze because they host a Yuri's Night event, but because they're a large nonprofit pro-space organization, primarily funded by industry, by the aerospace industry. They got a little pressure over calling it Yuri's night because of the invasion of Ukraine. So they talked about it and thought about it and agonized a bit and ended up changing it to a celebration of space, discover what's next due to complaints. Doesn't have quite the same ring to it. And I hope in successive years they'll be able to change it back to Yuri's night. Because honestly, I'm no fan of what Russia's doing. I don't think any of us are. But Yuri Gagarin wasn't a part of this Russia. You know, this was back in 1961, 62. He was a very brave guy. He flew the first human flight to orbit, and I think he deserves the respect for that. So, if I may suggest, let's just keep calling it Yuri's night. Thanks for listening. It's been a pleasure, and I want to thank you for joining me with this first solo episode for This Week in Space. You can send us feedback at twis@twit.tv. New episodes published every Friday and are posted to your favorite podcatcher, so make sure to subscribe. And please tell your friends if you enjoy this show, because the more the merrier. This is one big party. I want to hear from you. The more of you write in, the more I can take your direction and bring you things that you want to hear. You can follow the TWiT Tech Podcast Network at TWiT on Twitter and on Facebook and TWiT TV on Instagram. Thanks very much, and I'll see you again next week.
Listeners of this program get an ad-free version if they're members of Club TWiT. $7 a month gives you ad-free versions of all of our shows, plus membership in the Club TWiT Discord, a great clubhouse for TWiT listeners. And finally, the TWiT Plus feed with shows like Stacy's Book Club, The Untitled Linux Show, The Giz Fizz, and more. Go to twit.tv/clubtwit, and thanks for your support.